Okay, let's look at some examples. We can approach these problems in two different ways. I'm going to show you both of those ways. First, I'm going to look at number 1, which is the square root of 18. 18 is not a perfect square, but it contains a perfect square factor. So one way to find that perfect square factor is to use a factor tree. So I know that this number is divisible by 2, and 2 times 9 is 18. Then I can continue to break down the 9 to make 3 and 3. Now I would stop here because the numbers at the ends of the branches, 2, 3, and 3, are prime. Now what I'm looking for is a pair of the same number. Since there are 2 3's here, I'm going to pair them together and put them into their own radical. So I'm going to make this radical 3 times 3, and then the leftover number, that's going to go in its own radical 2. Now let's put these numbers together. 3 times 3, I know that that makes the square root of 9, and we'll keep the square root of 2. Now, since 9 is a perfect square, I'm going to take the square root of 9, which is 3. 3 times the square root of 2 makes our answer 3 square root of 2. Another way that I can do this from the beginning is if I'm looking at 18, I can look at its factors of 18. So looking at 18, I can see that the biggest factor of 18 that is a perfect square is 9. So right away I can break this up into 9 times 2 and then put them into their own radicals. Square root of 9 times the square root of 2. Then that gives me the same exact answer, 3 radical 2. Let's try this again with number 2. We're going to do radical 75. Again, I can do the factor tree. I know that 3 goes into 75 25 times, and then I can break up 25 to be 5 times 5. Again, I'm going to look for a pair of numbers. My pair of numbers here is 5. They're going to go into their own radical, 5 times 5, and then our leftover number goes into its own radical. So we can see why we're looking for a pair, because when I multiply this 5 times 5 together, it creates 25, and 25 is a perfect square. That's the factor that I'm looking to take out of the square root. So let's take the square root of 25, which is 5, times the square root of 3, and here's my answer, 5 square root of 3. Let's look at more examples. The square root of 33. Now, if I try to do a factor tree for this, the only factors that go into 33 are 3 and 11. Those are prime. There are no pairs when it comes to this number. That means that radical 33 is already simplified. It cannot be simplified because there are no perfect square factors inside of 33. Let's look at another example. Number 4, we're going to do the square root of 225. So what you might notice is that 225 actually is a perfect square. The square root of 225 is 15. So to simplify, 225 is the biggest perfect square. I'm just going to take the square root of 225 and I get my answer of 15. Now let's pretend like we were going to do the factor tree. Let's pretend we didn't realize that 225 was a perfect square. Well, I know that 5 goes into 225. How many times does 5 go into 225? Well, it goes in 45 times. Now let's break up 45. I know 5 goes into 45 9 times, and now we're going to break up the 9 to be 3 and 3. Okay, if I notice my 5's are both a pair and my 3's are both a pair. So if I were to put this underneath the radical, 5 times 5 and 3 times 3 would all go underneath the same radical. When I multiply them all back together, I get the square root of 225, and I know that's the biggest perfect square factor, so again, I'm gonna square root it, and again, I get 15. Let's look at more examples. We're gonna look at the square root of 108. So if you feel like you're not really liking this factor tree method, that's totally fine. You can try to use the rainbow method, or you can use your calculator to try to figure out what is the biggest perfect square factor inside of 108. 108 is kind of a big number, so maybe this one is a hard one to see. Let's do the factor tree. I know that 2 goes into 108 54 times. Let's break this up again. It's going to be 2 and 27. I can break up 27 to be 3 and 9, and then 9 can be 3 and 3. Let's find our pairs. Well, these 2's make a pair, and 3 3's, these 2 3's make a pair, and this one single 3 is left over. Let's put the pairs in their own radical. So 2 times 2 times 3, those were our pairs, times, in its own radical, the leftover number is 3. Let's multiply the pairs together. 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36, which means that 36 is the biggest perfect square factor inside of 108. So now let's take the square root of 36, and I get 6 square root of 3. Let's do another one. Number 6, we're going to do the square root of 80. Now, you could think of the biggest perfect square that goes inside of 80, but the problem is you have to find the biggest perfect square. So again, maybe we should do the factor tree. Let's break up 80 to be 2 times 40, and then 40 is going to be 2 times 20. 20 is going to be 2 times 10. And then 10 is going to be 2 times 5. Let's create our pairs. These 2's make a pair, and these 2's make a pair, leaving 5 left over. Okay, we're going to put the pairs under the same radical. So 2 times 2 times 2 times 2. And then the 5 is going to go in its own radical. Let's multiply these back together. 2 times 2 times 2 times 2, that's 16, which means that 16 is the biggest perfect square factor inside of 80. So now let's take the square root of 16, which is 4, and the square root of 5 stays.